Today, class, we'll be working in lesson 7.1 on operations on functions. So our operations, as shown here, would be to add functions, to subtract them, multiply them, and divide them. When we're adding functions, you can see this written as f plus g of x in this form, which basically means the same as f of x plus g of x. And then as we've done all year long, when we're adding, you basically combine like terms. Like terms being terms that have the same exact variable part. When you're subtracting, so if you have f minus g of x, that means the same as f of x minus g of x. Order being very important here. And like we've done all year, subtraction is adding the opposite. So we're going to change that subtraction to addition. Add the opposite of that second function. In multiplication, we are multiplying f times g of x, meaning the same as f of x times g of x. And then you're going to use distributive property. You could use FOIL if they're both binomials, if they're both two terms, and then combining like terms. Division's kind of unique. We're going to divide, so f divided by g of x is the same as f of x divided by g of x. You're going to factor, or you're going to look and see if possibly you might have factors that are common on the top and the bottom, and if there are, you can cancel those. Also looking if there's any restrictions on x, because this denominator part, this g of x, that cannot equal 0. So whatever makes that equal 0 is a restriction on what x can be. So a couple examples here, if you're given a couple functions and you're asked to perform operations with them. This first one here, we have f of x plus g of x. So that is simply your 3x plus 4, which is your f of x, plus your g of x, which is negative 2x minus 1. We just combine like terms. We'd have x, 4 minus 1 is a positive 3. Subtracting them, I like to write this all out. So I have 3x minus 4. I'm subtracting negative 2x minus 1. And then I'm going to add the opposite. I don't change that first function at all. Now it's an addition problem, so I combine like terms. And I'd have 5x plus 5. Multiplication, now I've got 3x plus 4. I'm multiplying by negative 2x minus 1. These are both binomials, so I'm going to FOIL. So you'd have a negative 6x squared minus 3x minus 8x minus 4. Combine those like terms. And your answer is a quadratic there, a second degree polynomial. Dividing. We're going to take 3x plus 4. We're going to divide by negative 2x minus 1. And it's fairly obvious at that bottom, that negative 2x minus 1 cannot be a factor of the top. So therefore, that's it. Your restriction here is that x cannot be whatever makes the bottom 0, which would be a positive 1 over a negative 2, or a negative 1/2. So x cannot be negative 1/2. Another example, here's an example where you've got a quadratic with 3 terms, and then you have another function with 2 terms. So if we're adding these, again, we're going to combine like terms. Two x squared is by itself there. No other like terms. We've got negative 5x and a positive x is a negative 4x. We've got a negative 3 and a negative 3, which would be a negative 6. Subtracting, I'm going to add the opposite. So I'm subtracting x minus 3. I'm going to add the opposite of that. And now I'm combining like terms. So again, I would just have the 2x squared minus 5x and a minus x is a minus 6x. minus 3 and a plus 3 is 0. That cancels out. Multiplication. We're going to take f of x and multiply by x minus 3. I'm going to distribute. So I've got 2x cubed minus 5x squared minus 3x. Then I'm going to multiply each term by the negative 3. So I have a negative 6x squared. I have a positive 15x. And I have a positive 9. Combining those like terms, 2x cubed minus 11x squared plus the 12x plus 9. Then we've got division. I'm going to take 2x squared minus 5x minus 3. I'm dividing that by g of x, which is x minus 3. And now I'm going to check and see. Now obviously x cannot be 3 because 3 makes that denominator 0. But I might want to check and see, is x minus 3 a factor of the top? So if I would factor this, and I would just put the x minus 3 in there, which means my other factor would have to be 2x, because my first terms have to be 2x squared. This would have to be plus 1. And if you check and see if this works, it does. Your outsides and insides do give you a negative 5x. So x minus 3 is a common factor of the top, which would cancel. And you'd be left with 2x plus 1. So that's an example of operations on functions: addition, subtraction, multiplication, division. In the next video, we'll talk about is composition of functions.